Hi there, I'm Dr. Bob. Today I'm going to be teaching about one of the more deadly viruses in this world, the Ebola virus. Specifically, I will touch on the etiology and the pathogenesis of this virus. So please.
Before we get into the etiology and pathogenesis of the Ebola virus, I thought that it might be prudent to introduce this virus. So, first off, the Ebola virus was discovered in 1976 under interesting conditions. It turns out that in this year there were two simultaneous outbreaks originating in Africa, one in Sudan and one in the Democratic Republic of the Congo. In addition, this virus is a highly virulent and lethal virus that is characterized by being very readily disseminated from person to person. As such, the CDC has categorized it as a Category 4 pathogen. So, the Ebola virus belongs to the Filioviaridae virus family. This family is characterized by having a antisense or negative strand RNA genome, single-stranded. In addition, they are always lipid encased. They're not naked viruses or virons or something like that. So the Ebola virus, it turns out, something that they did not expect in 1976, but it turns out that this is true now, is that Ebola is not just one disease. It's actually now a genus that has 4 species subtypes. So there is Zaire Ebola virus, there is Sudan Ebola virus, and there's Ivory Coast Ebola virus. Beyond this, the Reston Ebola virus is a type of Ebola virus that does not infect humans. Rather, it is primarily seen in non-human primates such as great apes or orangutans or other types of high-order primates. So now, moving on to the etiology of the Ebola virus, one thing must be made clear. The 5 species subtypes of the genus Ebola virus are all classified as viral hemorrhagic fevers. That's the disease that is associated with this virus. Now, the etiology of the viral hemorrhagic fevers is the Ebola virus, and it isn't the other way around. In every single form, the fatality rate is 50 to 100%, making it a very, very powerful and lethal virus. The Ebola virus is believed to be zoonotic in origin, coming from some animal that somehow transferred over to humans. The natural reservoir, meaning the primary host, the animal that carries the actual virus, that maintains it and keeps it in the environment, is currently unknown. However, recent research has led researchers to believe that the fruit bat may indeed be the natural reservoir for the Ebola virus. The fruit bat actually carries with it basal levels of the Ebola virus and eventually does succumb to the virus, and during which time, during hemorrhagic states, will actually excrete blood infected with the Ebola virus and somehow gets picked up by passerbys and leads to infection in that way. Now, the secondary host, as we know, is human and non-human primates. This seems to be the only cases that we've been able to find of the natural occurring Ebola virus, and not, murine models or stuff like that. The way that the Ebola virus is spread is mainly through bodily fluids, blood, excretions, tissue, semen, nosocomial, or in hospital settings with, especially in third world countries with reusing needles and stuff like that. This is where you see a lot of Ebola virus infections in these settings. In addition, the primary entry route is through either the conjunctiva, the eyes, or the mucosal membranes. So wherever that is, there's the lips, the genitalia. At this point in time in the presentation, we are going to switch from an etiological perspective to a pathogenesis perspective relating to the Ebola virus. When thinking about the pathogenesis and progression of the Ebola virus, we can group the pathogenesis into three broad range categories. The first category is the incubation stage. During this time, between 4 and 10 days after infection, the Ebola virus has fully disseminated through the host body and is now trying to gain a foothold in the system. It's doing this primarily at this point by attacking the innate immune system and causing overall immunosuppression. And after this is done, it will become much more of a severe infection. Now, the next stage is the replication stage. This stage overlaps the incubation stage and the final stage, which is the terminal, that I will get to in a second. The replication stage is characterized by rapid viral replication and subsequent host cell lysis due to the nature of viral reproduction, and this causes massive necrosis of organ tissue, vascular tissue, pretty much all the tissues in the host body, but especially relating to the cardiovascular and underlying endothelial cells within the vessels. The final stage, the terminal stage, is at the point where the host's immune system has been almost completely compromised, either by inhibition or destruction, and the replication stage is still present, causing further damage. It is at this point that the replication stage will cause a extreme amount of necrotic tissue and just overall massive cell death within the host, especially targeting the endothelial vessels, the endothelial cells of the blood vessels, and will eventually lead to massive hemorrhaging, which will possibly lead to septicemia or eventual death, most likely through shock. So this is not a very pleasant way to die. This usually occurs between 7 and 16 days after infection if the host's immune system has been fully understood.